A while ago, I made a breadboard module of an envelope follower. At the time, I really didn't have much use for it, so I went on to use that breadboard for other things. Then, earlier this year, I was contacted by someone who was interested in having that breadboard turned into a guitar pedal. So after some back and forth about the details of the design, this pedal was born. For those of you playing at home, this is the schematic for the pedal. After completing that project, I thought that since the guitar pedal started as a Eurorack module, I should turn the pedal back into a Eurorack module and make a video about it. And here we are. With the backstory out of the way, let's look at the schematic that we are going to use today. Input signal comes in here, DC bias is removed by capacitor C2, and the output from the op-amp passes through a potentiometer to set the gain of the following stages. Having a gain control is useful because it allows you to adjust the sensitivity of the module to work with subtle sounds and louder sounds, and still get the entire dynamic range out of the module. This op-amp boosts the signal after the gain potentiometer and sends it to the next stage, which is an ideal rectifier. Others can explain how this works better than I can. However, the results of this stage is the input signal is converted to all positive voltages without any losses across the diodes. Now for the complicated part. Capacitor C1 holds the voltage that sets the output of the system. It is charged by this op-amp here, and the charge rate is set by the attack potentiometer here. At the same time, capacitor C11 is also charged. C11 has a fixed discharge through R15, a 22 kilo ohm resistor. Capacitor C1 and C11 are both connected to op-amp IC2D. This op-amp acts like a comparator and only turns on transistor T1 if the voltage in C11 is less than the voltage in C1. So what does this do? Transistor T1 only turns on when the input signal is declining, which separates the attack and decay events, which allows for separate controls for each. Without this part of the circuit, a long decay and a quick attack, or vice versa, would not be possible. Okay, with that out of the way, the voltage held in C1 is output through this op-amp here. The two potentiometers here, which are mounted to the PCB, adjust the zero voltage and set the maximum output level. Zero adjust is needed because discharge of capacitor C1 is through a bipolar junction transistor. When you discharge through this type of transistor, you can never discharge all the voltage in the capacitor. Potentiometer R6 compensates for this by providing an offset voltage to the op-amp. Potentiometer R13 allows for a maximum output level to be set so that the input, whatever this module is connected to, doesn't clip. The final pieces are all housekeeping, power connector, decoupling caps, etc. Now let's build it. Engraving the resist on the PCB. Laser cutting the faceplate. Cutting out the PCB. I finally made a fresh batch of ferric chloride. And with the tarnish removed, into the FeCl3 it goes. These half-ounce copper PCB boards always come out perfect. With the resist removed, time to drill some holes. Now to mount everything to the faceplate. Assemble the PCB. Mount the PCB to the faceplate. Got to remember to put on the red stripe. A quick smoke test later. And into the rack it goes. With both the attack and decay potentiometers turned down, the envelope of the output follows the input signal as expected. Now here's where the improvement is over the original module. We can set up a quick attack and a long decay like this, or a long attack over many notes that falls off quickly like this. Now for a quick sonic example of what this could be used for. Say you want some LFO on your notes, but you want it to come in slowly. Just patch the output of the envelope follower into a VCA along with an LFO, and patch the output of the VCA into a pitch input on your VCO, and you have something like this. Of course, this could also be used to control reverb or a wave shaper or anything else that you could think of for the output of this module. So there you have it, an improved version of the envelope follower breadboard. Hope you have enjoyed, thanks for watching, and I'll see you next time.